These are the solutions to the questions at the end of lesson 10.3. Now, number 1, we know that dispersion is m over d cos theta. So if d becomes smaller, this little d becomes smaller, then the dispersion is larger. So that is C. Now 2, it is B because the wavelength is comparable to the size of the spacing between atoms. 3, we would have the central maximum having both blue and red, so the purple look, and then red will be diffracted more, so that is B. Now, number 4, we have d sine theta equals m lambda. Now, let's look at grating number A. We have 2,000 lines per metre, so that means the spacing between the lines for A is 1 metre over 2,000 is 0.5 millimetres. Now, we're talking about adjacent fringes, and that always means m equals 1. So again, we've got ratios, so we don't even have to work out the wavelength because we know that dA sine theta A equals m, which is 1 times lambda, and we know that dB sine theta B also equals lambda. So going from this one, we have dA, we'll put it in terms of spacing on the screen, so YA over D, and then we've got dB YB over D equals lambda. So we're really ending up with dA YA equals dB YB. So since the dB is what we're interested in, the spacing for D, it is YA over YB times dA, which is 2.7 times 3.2 times the 0.5 millimetres, which is 0.42 millimetres. So the spacing in terms of how many per metre is 1 metre over 0.42 millimetres. Sorry, that was millimetres. So was that. Is 1 over 0.42 by 10 to the minus 3 is about 2,370 lines per metre. Now, number 5, we have D is 6.25 by 10 to the minus 6 metres as the spacing between lines. We know it's the third order, and we're told it is 18 degrees. So m lambda equals d sine theta. M is 3. Lambda equals d sine theta. So lambda is d sine theta over 3, which is 6.25 by 10 to the minus 6 times sine of 18 degrees over 3, which is 6.43 by 10 to the minus 7, which is 643 nanometers. Number 6, we have for the X-ray diffraction, remember the equation is just slightly different, is 2d sine theta equals m lambda. Now we have d equals 0.281 nanometers, lambda equals 0.140 nanometers, and it's first order. So we have sine theta equals m lambda, just taking sine theta on its own, over 2d is 1 times 0.14 by 10 to the minus 9 over 2 times 0.281 by 10 to the minus 9 equals 0.249. So theta is sine to the minus 1 of that is 14.4 degrees. And finally, number 7, we have lambda equals 1.54 angstroms, which is 1.54 by 10 to the minus 10 meters. We have theta is 22 degrees for the first order, which is m equals 1. So we have 2d sine theta equals m lambda. So 2d sine of 22 equals 1 times 1.54 by 10 to the minus 10. So that gives d equals 1.54 by 10 to the minus 10 over 2 times sine of 22, which turns out to be 0.3746. So d is 2.06 by 10 to the minus 10 meters, which we can write as 2.06 angstroms.